Imagine a missile that travels 5 times faster than the speed of sound, can change direction mid-flight, and strikes its target with near-zero warning. A weapon so fast that even the most advanced defense systems can't stop it. This isn't science fiction. This is the terrifying reality of hypersonic missile technology. From Moscow to Beijing to Washington, the world's major powers are racing to master this revolutionary new class of weaponry. But this isn't just about speed. It's about strategic dominance, first-strike capability, and the power to tip the global balance of military force. In today's video, we dive deep into the world of hypersonic missiles, how they work, who controls them, what threats they pose, and how this arms race could redefine the very nature of warfare in the 21st century. What makes a missile hypersonic? To be classified as hypersonic, a missile must travel at speeds above Mach 5, more than 6,100 kilometers per hour. But hypersonic missiles go far beyond raw speed. What makes them uniquely threatening is a combination of several factors. Speed renders traditional radar detection and response windows nearly obsolete. Maneuverability allows them to evade interceptor systems by changing trajectory in flight. Altitude. They fly lower than ballistic missiles but higher than cruise missiles, creating a detection blind zone for many current defense systems. Precision. Advanced onboard guidance systems allow pinpoint accuracy at hypersonic speeds. Unlike intercontinental ballistic missiles, ICBMs, which follow a predictable parabolic arc, hypersonic missiles can glide, twist, and dive, making interception almost impossible using current technologies. Two main types of hypersonic weapons. 1. Hypersonic glide vehicles, HGVs. Launched aboard a traditional ICBM, an HGV detaches in space and re-enters the atmosphere at hypersonic speeds, gliding toward its target unpredictably. Examples include Russia's Avangard, China's DFZF. 2. Hypersonic cruise missiles, HCMs. Powered throughout flight by high-speed engines such as scramjets, supersonic combustion ramjets, these missiles maintain sustained hypersonic velocity at low altitudes. Examples include Russia's Zircon, the US HAWC, hypersonic air-breathing weapon concept. Each design has its own advantages. Glide vehicles offer longer ranges and unpredictable flight paths, while cruise missiles are more compact, tactically flexible, and ideal for conventional strikes. The science behind the speed, how hypersonics work. At the heart of hypersonic technology lies cutting-edge material science and thermodynamics. When a missile moves at Mach 5 or more, it faces extreme air resistance and temperatures exceeding 1,000 Celsius. This creates several engineering challenges. Thermal shielding requires special alloys and ceramics that won't melt during flight. Flight stability. Maneuvering at hypersonic speeds introduces turbulent aerodynamic forces that can rip an object apart. Communication blackouts. Plasma formed around the vehicle during flight can block radio signals, complicating real-time control. Overcoming these barriers requires national-level investment, breakthrough technologies, and world-class research institutions. Only a few nations have all three. The strategic significance, why the world is racing for hypersonics. The allure of hypersonic missiles isn't just technological, it's geopolitical. These weapons offer game-changing capabilities that threaten to upend decades of strategic balance. First strike advantage. Hypersonics could hit an enemy's command and control centers before a counterstrike is even possible. Conventional prompt global strike. Some hypersonic systems are designed to deliver non-nuclear warheads anywhere on Earth within minutes, ideal for hitting time-sensitive targets like mobile launchers or terrorist leaders. Nuclear deterrence reinforcement. For countries like Russia and China, hypersonic missiles act as a warning to adversaries. We can bypass your defenses. This makes them not just weapons, but tools of diplomacy and power projection. Russia, leading with aggression. Russia is arguably the current global leader in operational hypersonic technology. Its systems include Avangard, a nuclear-capable HGV that can travel at Mach 20, launched from an ICBM and capable of maneuvering unpredictably. Kinjal, an air-launched ballistic missile capable of Mach 10 speeds used multiple times in Ukraine. Zircon, a ship-launched scramjet-powered cruise missile with speeds exceeding Mach 8 and a range of 1,000 kilometers. Moscow sees hypersonic weapons as a way to offset NATO's conventional superiority. By threatening key infrastructure like naval fleets and air bases, Russia can deter Western intervention near its borders. China, rapid ascent through innovation. China's hypersonic program is perhaps the most alarming due to its secrecy and rapid development. Notable systems include DFZF, a deployed HGV capable of both nuclear and conventional payloads, launched from the DF-17 missile platform. Starry Sky 2, Sing-Kong 2, an experimental Wave Rider hypersonic vehicle capable of Mach 6, indicating advanced scramjet progress. Fractional Orbital Bombardment System, FOBS. Allegedly tested in 2021, this system could allow a hypersonic warhead to orbit the Earth before descending unpredictably on a target, a possible game changer. These technologies give Beijing the capability to threaten U.S. bases in the Indo-Pacific, potentially neutralizing American deterrence in a Taiwan conflict scenario. The United States, closing the gap. The U.S. was late to the hypersonic race, but has accelerated efforts dramatically. DARPA projects, including Hawk and the Tactical Boost Glide (TBG) program. ARW, the air-launched rapid response weapon launched from a B-52 bomber, is undergoing testing for operational deployment. LRHW, long-range hypersonic weapon, a ground-launched hypersonic missile intended for use by the U.S. Army. The Pentagon is also investing heavily in defense systems against hypersonics, including space-based sensors, AI-enhanced tracking systems, directed energy weapons. Washington's goal is not only to develop its own hypersonic strike capabilities, but also to build a multi-layered defense network capable of neutralizing future threats. Other countries entering the race. While the US, Russia, and China dominate, other nations are entering the hypersonic arena. India is developing the Shaurya and Hypersonic Technology Demonstrator Vehicle. France, the UK, and Australia are collaborating with the US on research through the AUKUS partnership. North Korea has claimed successful hypersonic tests, though their credibility remains debated. The spread of hypersonic technology increases the risk of regional instability and proliferation, making it harder to manage future crises. The future: hypersonic defense and arms control. Stopping hypersonic missiles is far more complex than traditional missile defense. Some possible solutions include constellations of low-orbit satellites to track launches in real time, directed energy systems like high-powered lasers or microwave weapons, AI-powered interceptors capable of predictive trajectory modeling. But technological solutions may not be enough. There's growing international pressure to establish arms control agreements for hypersonic weapons, introduce no first-use policies or flight test transparency protocols, prevent the spread of hypersonic tech to rogue states. So far, no binding international treaty governs the development or deployment of hypersonic weapons, a dangerous gap in global security architecture. Conclusion: the final frontier of warfare. Hypersonic missiles represent more than just the next step in weapons technology. They are a paradigm shift in how wars might be fought. Faster, smarter, and harder to defend against, they compress the time between detection and destruction into mere seconds. This creates new possibilities, but also new nightmares. Unless carefully managed, the hypersonic arms race could destabilize existing balances of power, increase the risk of miscalculation, and push the world toward a more volatile future. The question is no longer whether the hypersonic age has arrived. It has. The real question now is, can humanity control the consequences?